Okay, so here's a problem asked over email 1.5.17, and they ask us to find all real solutions x minus 12 over 3 minus x, and x plus 18 over x plus 6. So when we have one fraction equal to one fraction, what we can do is we can actually cross multiply. And that means taking this numerator times that denominator and setting that equal to this denominator times that numerator. So it's going to look like this: x minus 12 times x plus 6. We have to remember that we're multiplying the whole quantity here. So I have to put parentheses around each of these to denote that I'm multiplying the whole quantity. And that means that we're going to have to FOIL here in a minute. Okay, so this is going to be 3 minus x times x plus 18. Okay, all right, so if I FOIL here, the first is x squared. Outside is 6x. Inside, negative 12x, and last is negative 72. If I FOIL over here, I get 3x for the first. Outside is a positive 54. Inside is a negative x squared, and the last is a negative 18x. Okay, let's collect like terms on both sides. We have x squared minus 6x minus 72. On this side, these two combine to give us a negative 6. On this side, I'm going to rewrite it with my x squared first, and it's negative. I've got a 3x and a negative 18x. So that'll give me negative 15x, and then plus 54. Okay, so I see the highest power on x being a 2. So I'm thinking this is a quadratic, and the way that I'm going to solve it is by setting it to 0. So I'm going to take all of this to the other side, which means adding x squared, adding 15x, and subtracting 54. Okay, so I'm going to get 0 on this side. On this side, I'm going to get 2x squared. 15 minus 6, I get 9x, and this is a minus 126. Okay, now that factors. If it didn't factor, if you tried it and you couldn't get the factorization, you would just stick it into the quadratic formula. But because it does factor, I'm going to go ahead and do that. And so I see if I use a 2x and an x, and if I use a 6 and a 21, and 21 times 6 will give me 126. And notice outside will give me 12, inside will give me 21. So I needed positive 9. So if I make this positive and that negative, it'll work. And if I check the last, positive times negative is negative. So that works. So I'm going to set each of these pieces to 0, 2x plus 21 to 0, and x minus 6 to 0. Okay, so subtract your 21, 2x equals negative 21, and then divide by 2. So x equals negative 21 over 2 is a possible solution. Over here, when I add 6, I get x equals 6. Now, when you're working with rational equations, you have to go back to the original problem and make sure that neither of these will give you 0 in a denominator. And you'll notice that neither of them give a 0. Negative 6 would give 0 here, positive 3 would give 0 there, and those would be undefined values. But neither of these values are one of those, so both of these are solutions.